Welcome back. I hope you won't mind if I do a brief recap on Canadian wood and our journey in India so far, before I get into today's topic, which looks more closely at building techniques and detailing. Now that's going to give us an insight into the many FAQs from past seminars and events. One point of clarification, in this presentation, I do talk about Canadian wood as a species group, and I talk about Canadian wood as an organisation. So Canadian wood as an organisation is a crown agency of the government of British Columbia, as Nirmala said, BC being the westernmost province of Canada. And we have a mandate to promote Canadian forest products in the export markets. We're a not-for-profit organisation, fully funded by the BC and Canadian governments. And so we don't engage in any commercial activity. Canadian Wood, the organisation, started with a small office in India in 2013, has since grown to a total staff of 20 people. It's quite a big investment. We're working out of 3 offices, comprising our head office in Mumbai and 2 satellite offices, one in Gurgaon, excuse me, and one in Bangalore. So I'd like to commence the session with a 5-minute video shot in British Columbia, which gives an overview of the Canadian lumber industry. Some of you will have seen it before, but I'm sure it'll still be insightful. And the video is going to lead us into wood building techniques used in India, with the emphasis on Canadian wood as a species group. So I'll get started.
There are few places on Earth that can match the diversity and richness of Canada's forests. Forests are an important part of Canada's natural ecosystem and central to its economy, making up just under half of its landscape with 8 major forest regions and a vast diversity of wood species. From planting a seedling to manufacturing lumber, the forest sector in British Columbia and Canada is an interconnected industry of forest management and wood processing. This includes planting, tree harvesting with modern, high-tech machinery, and sophisticated wood product manufacturing. The entire cycle is planned around responsible resource management. In British Columbia, forestry and wood product manufacturing are a fabric of our culture, our communities, and our people. Our forests provide a sustainable supply of wood for lumber and mass timber products, while protecting our environmental and social values of wildlife, water, community, economic interests, and First Nations peoples. British Columbia is a global leader in sustainable forest management. Forestry practices in British Columbia ensure that environmental, social, and economic needs are met for current and future generations. This matters to our customers and sets us apart from other supply regions globally. Wood products from British Columbia come from legal, sustainably managed forests. By law, less than 1% of the forests are harvested annually, with 3 trees planted for every single tree harvested. This commitment to forest regeneration results in 200 million new seedlings planted every year, ensuring replenished forests for the future. Canadian wood suppliers provide certified products under the Forest Stewardship Council, FSC, and the Program for the Endorsement of Forest Certification, PEFC. These strict international certification standards add additional assurance of the global protection of forest resources and make Canada a reliable and sustainable provider of wood products. State-of-the-art technology and machinery, incorporated in our forestry practices and through our highly productive, efficient sawmills, support the production of Canada's quality lumber. After harvesting, logs are transported to sawmills for manufacturing. At the sawmill, the logs are cut to target lengths and loaded into a debarking machine to remove the bark. Next, logs are processed through primary breakdown equipment like head rigs and chip-in saws and are turned into lumber. The lumber is then sawed to specific widths and trimmed to specific lengths as it passes through secondary equipment like edgers and trimmers. A scanner will show if the lumber requires any further trimming. Next, the lumber is sorted by thickness, width, length, and sometimes by grade attribute. It is stacked, which may include stacking on sticks for kiln drying. When the lumber is dry, it is ready for final processing. Some lumber goes through a planer mill to be made smooth. Whether planed or rough, the lumber is then graded and trimmed. It is sorted by size and by grade, then finally packaged for shipment. This results in the most efficient yield of the best quality lumber. Once the lumber is packaged and prepared for shipment, it is loaded onto a network of trucks and rail cars for delivery to shipping ports for distribution around the world. Independent studies confirm that the CO2 stored in wood products far outweighs any extra CO2 generated by the efficient manufacturing and shipping of Canadian lumber around the world. Lumber produced from British Columbia and Canada is durable, strong, and versatile. Superior working properties offer design flexibility and durability. Canadian lumber products can be bent, shaped, or assembled as required, making it ideal for countless indoor, outdoor, and structural applications such as windows, doors, gazebos, and furniture like tables and chairs. Canadian wood species are also easy to face laminate, edge glue and/or finger joint, and standard sizes and grades ensure that the same high-quality product reaches the client each time. Canadian wood products bring warmth and natural beauty to an interior and exterior application or furniture product. It can be sanded to create a smooth surface, has a superior coating adherence, and can easily take any stain or finish. Across Canada and North America, wood products are influencing design and construction, not only for interior and exterior applications, but also the construction of buildings. Mass timber products are changing the way buildings are constructed, allowing for immense spans and taller buildings made of wood. Canadian wood products are being used in a wide range of buildings and products, showcasing the versatility, strength, and durability of lumber from Canadian forests. That is why using Canadian wood is a natural choice.
So it's important to note that India is a fibre deficit country. Therefore, India needs to import wood and is importing wood to augment its local supply. The message in the video is that Canada provides a reliable supply of sustainable, certified and versatile lumber. And in India, we have identified several key markets which are benefiting from access to this Canadian resource. One of those key markets is structural applications, or put another way, building with wood in India. In fact, Canadian Wood has already partnered with several manufacturers in India to build display homes featuring 3 distinct building styles. Those building styles are post and beam, prefab T&G, and wood frame construction. Here are some examples of our projects in India. This clubhouse by Artius on the left, and a villa by Akar Design and Buildcraft, who are all Delhi-based manufacturers, are fine examples of post and beam made in India. And we're very much a team effort with Canadian Wood. The clubhouse on the left features yellow cedar, Douglas fir, and spruce pine fir glulam, while Kapoor Villa on the right features solid Douglas fir lumber for the posts, beams, and roof trusses. In prefab tongue and groove, Canadian Wood collaborated with Ekbote in building Taljai Forest Lodge, pictured here at Constro 2020 in Pune. And we collaborated with Delhi-based Wood Barn in the construction of their outstanding display house exhibited at IndiaWood 2020. The construction style for both of these homes is prefab T&G, meaning prefabricated and profiled solid wood with interlocking joints. The third building technique promoted by Canadian Wood is North American style wood frame construction. This time in cooperation with Pyramid Timber Associates and Mars Furniture, based in Mysore. The 3,000 square foot multi-level house features all Canadian species, all of our Canadian species inside and out. And further examples of our efforts in wood frame construction are exemplified by these display houses in Bangalore and Chennai, built in partnership with 9 Wooden Homes and Wood Nido. Bangalore project is a small single-level resort cabin just 375 square feet in area, while the wood Nido house is mid-size and features this stunning Western red cedar and plywood spiral staircase leading to a mezzanine and outside deck. Both houses use SPF framing, yellow cedar doors and windows, and Western red cedar cladding. And all the houses that you see here today are open for your inspection at the various locations. So please do try and go along and have a look in person. Including another recent collaboration with Pyramid Timber, in this case, a modular wood frame construction. As you see here, there are 3 modules, each about 10 feet wide by 30 feet long, which were built at the factory using spruce pine fir framing and roof trusses, structural OSB imported from Canada, and featuring Canadian species throughout in the fit and finish. So as you can see, our team at Canadian Wood has been very busy working with various partners, spreading the word about building with wood in India, and not only talking about wooden homes, but investing our time, resources and effort to show the proof is in the pudding. In every case, wood allows prefabrication, easy transportation, a light footprint and big savings on footings and foundations. Wood is quick to build, it's easy to work with, easy on tools, easy to handle on site and eco-friendly. And wood's also energy efficient. It's easy to modify during and after construction, suited to steep and forested sites, but equally at home on the beach, and offers seismic performance, look and feel, health benefits. I could go on and on. I think you get the idea. So let's take a look now at each building method and at the same time address those frequently asked questions. So firstly, what is post and beam? You might recognise this stone structure. It's more like post and lintel, but the concept is the same. Timber post and beam construction, not quite this old, but certainly dates back to the 1600s. And it's a building method that relies on heavy timbers rather than dimensional lumber. The vertical posts and horizontal beams are structural members, jointed to form a structural frame, into which walls are placed. Contemporary post and beam construction often uses modular techniques as well, whereby subsections such as wall panels are prefabricated before being hoisted and bolted into place on the job site. In North America and Europe today, engineered glulam has become more predominant in post and beam due to the larger sections and longer spans required. The advantages of glulam are the moisture content of the wood, added strength and stiffness, large end sections allowing very long spans, and availability in precise lengths and exacting tolerances. The use of large timbers or glulams in post and beam means fewer support beams are needed, and since the frame carries the roof load, the number of interior walls can be reduced, thus creating a bold architectural statement, as you see here, and dramatically open interior spaces, which can be simply stunning, as we can see. Post and beam construction is very flexible and can be used to create interesting and dramatic features. For example, an entire gable end can be used for a double height window, using beams at the top of the glazing to bear the load of the roof. Again, in this slide, beams at the top of the glazing bear the roof load, allowing large windows in this light-filled, open-plan bathroom. Here are some examples of post and beam construction in Canada. This building is a lodge and shopping complex using solid Douglas fir posts and beams and Western red cedar vertical cladding. And these are all private residences using a mix of solid Douglas fir timbers and spruce pine fir and Douglas fir glulams. Note the resulting large open spaces which are, facilitated by the post and beam style. Sometimes diagonal posts are required to resist the, lateral loads in this building style. Here are some examples in India. This is again Kapur Villa, which we saw earlier. In post and beam style, it's usual for posts and beams to be visible inside the building, while the exterior skin hides them on the outside, which may use a variety of cladding materials, in this case, local stone. This means post and beam buildings are sometimes difficult to recognise from outside. It is worth noting, post and beam construction can be more expensive than prefab TNG and wood frame construction due to the larger wood sections and precise CNC cutting and drilling. Also, the inclusion of custom-made connections and hardware can add to the cost. The tendency toward using glue lamp, which is not commercially available in India as yet, and sometimes additional labour required. The prefab TNG building style is quite different. Prefab TNG is a fast and efficient method of factory-made, hence prefabricated, profiled and notched members, which are stacked horizontally and interlocked at wall junctions, without the need for metal fasteners. But a word of caution, please. Prefab TNG, this style, has been growing in popularity across resorts in India, usually driven by lower cost. But please remember, we usually get what we pay for. Unfortunately, we've seen too many examples which are substandard and amateurish, suffering from poor building practices, inadequate wall thickness, shrinkage issues, poor coatings, and no detailing for termites or weather management. This can give this kind of structure a bad name. Can you imagine if each horizontal plank in a wall shrinks or swells just 1.5 millimetres in width? Multiply that by 26 planks in the walls in this house, and you would have 39 millimetres or 1.5 inches total shrinkage in a wall, perhaps more. So this is the reason for the gap that you see here. So product knowledge and best practices are essential when executing such projects. After all, it's your reputation on the line. So please make certain that you work with professionals who have a good knowledge and best practices. The prefab TNG system is time tested over decades, but like any system, rules and best practices must be followed. Prefab TNG is reminiscent of a log house system. Instead of logs, we are using accurately squared or shaped lumber. Each piece identical in end section, but notched and trimmed to length to allow the individual planks, often numbered, to easily slot together at the job site. In this slide, we see examples of triple laminated single tongue and groove, double laminated single tongue and groove, and solid wood double tongue and groove. At Bote have used a double laminated double tongue and groove profile in their 70mm wall thickness, achieved by glue laminating SPF J grade. Whereas Wood Barn incorporated a single tongue and groove in their glue laminated walls. Single tongue and groove versus double tongue and groove is personal choice. There's no real major difference in the two styles. The key to a high quality TNG system endorsed by Canadian Wood is wall thickness. Let me repeat that, wall thickness, which provides added strength, stiffness, and longer spans. 70mm wall thickness is best achieved by glue laminating 38mm SPF J grade. And remember, when face laminating, particular attention must be paid to the moisture content of the wood, which should be around 10%, plus or minus 2%. The correct orientation of the boards is important, meaning sap to sap or pith to pith. and the glue line, which must be a high quality, waterproof D4 adhesive applied with the correct clamping pressure and duration. In prefab TNG, special attention must also be given to windows, doors and trim where a vertical member is fixed to stacked horizontal members. This is a shrinkage issue. And the reason for this detail is that wood absorbs and releases moisture with changing humidity and will tend to swell or shrink accordingly. We can't stop that, but we can accommodate it. Since tangential shrinkage in wood, that is across its width, is greater than longitudinal shrinkage along its length, we must allow for this differential movement. One way is to fix our vertical member firmly at one end only, while employing an elongated vertical slot or key at the other end, which allows or lag screw to move up or down inside the slot as the horizontal planks expand and contract. Not difficult, it's an important detail. Prefab TNG style has the advantage of being easily pre-coated in the factory and is economical and quick to build. As can be seen in the following short video taken at IndiaWood this year. Please watch. Outstanding. So there you have it, a house erected in under 12 hours. Beautiful work. Further benefits of prefab TNG include the fact that this design can be viewed as a temporary structure, meaning it can be easily disassembled and moved if required. Yet it will still last for decades if properly maintained. And this style gives maximum wood visibility, plus that look and feel, which is a prerequisite for many people we talk to in India. A variation on the theme of prefab TNG are these resort cottages in Kerala, where the technique is a combination of two independent TNG walls connected via vertical studs. The outside wall uses 47mm single TNG Douglas fir, and the inside wall 38mm single TNG spruce pine fir, separated by studs, thus creating a cavity wall with an overall thickness around 125mm. Quite similar to a wood frame construction wall. And that wall accommodates electrical and plumbing services and provides space for installation. Once again, we must make allowances for shrinkage in the horizontal planks in relation to the vertical studs by locking verticals at one end and securing the other end with our countersunk lag screw through vertical slot. Important detail. Now let's take a look at how we build in the wood frame construction method. Did you know that life expectancy of a wood frame house with concrete foundation can be well over 100 years, provided the home has proper maintenance and care? I think that goes for almost any building, no matter what materials are used. The maintenance and care is a really important aspect. And building with wood is based on a process and a system which is high on detail. It's not difficult, but the details must be taken care of. In other words, no shortcuts. The system comprises load-bearing walls and partitions and non-load-bearing walls and partitions. All components of the system are drawn in conjunction with, usually with a software package, which gives detailed instructions and produces a cutting list for each panel or truss or roof or floor. To illustrate the process of building in this style, I thought I'd use the example of our very first wood frame construction house made in India. Earlier I mentioned this 3,000 square foot house was built in partnership with Pyramid Timber and Mars Furniture in Mysore. We started with clearing the site and treating the soil for termites, then laying a gravel base and placing a 6mm plastic vapour barrier between the gravel and the concrete, before tying the steel and pouring a foundation. Key points for site preparation and foundations are removal of any roots, trunks and scrap wood, chemical treatment of the soil with a termiticide, as I mentioned, deploying a plastic vapour barrier, ensuring the foundation is level and square, really critical, positioning anchor bolts properly as per the foundation drawing, or if building on piles, posts and platform, ensure levels and spans are measured accurately. And finally, ensuring that drainage detailing directs all water away from the foundation perimeter. But while the foundation is prepared, we can make wall frames in the factory based on our working drawings. Typically, 13mm OSB sheathing is also fixed to the wall panels at this time. Once the foundation is cured, we stand up the prefabricated wall panels and attach bottom plates to the concrete via cast-in-place anchor bolts, ensuring a felt gasket separates the hygroscopic concrete and the hygroscopic wood plates, as can be seen here. However, at this stage, there's an important detail which must be added before we stand the walls. I'm talking about termite flashing, which provides a physical barrier to subterranean termites and or allows termite mud tubes to be easily seen and eradicated. Note how the termite barrier is installed between concrete foundation and the timber base plate of the wall frame. This wall section diagram shows the termite flashing with felt gaskets above and below, providing separation from concrete and separation from the sill plate. Note the sill plate is pressure treated against decay and termites as an additional layer of defence. And termite flashing itself can be manufactured from galvanised metal, powder coated aluminium or copper sheet. Did you know that another term for wood frame construction is platform frame? This name comes from the idea that we use our concrete foundation or platform to support 4 walls and another platform. Then we use that platform to support 4 walls and another platform, and so on. That was the progression with this house in Mysore. Once the ground floor wall panels are standing with OSB sheathing attached, they are temporarily braced in position. And we commence with the next level, floor joists. With the floor joists installed and the ground floor enclosed by the first floor platform, we can now store our materials inside and under cover. And move up to the framing of our first floor. Similarly to below, with the floor joists and the 19mm OSB subfloor installed, we again stand the wall frames, which are temporarily braced. Note OSB sheathing is 90% attached before the wall panels are placed. Also note the nailing patterns and correct fasteners are paramount when nailing or when attaching OSB to wall and floor panels. As before, we can now install another layer of floor joists and OSB subfloor. And in so doing, we create a new platform, which becomes our level 2. The opening in the floor, seen here, will accommodate a staircase between our first and second levels. And here is the rough staircase on the left, installed at the first floor level, which is now enclosed except for the windows. Our internal walls have been installed and engineering details have been followed as per our working drawings. Note the metal hangers supporting 2x10 floor joists are attached to a 3-ply nail laminated SPF beam, otherwise known as a built-up beam. With the second platform complete, we commence the roof installation using 24-foot lengths of Douglas fir 2x12 to accommodate the architect's vision of a large attic room plus bathroom. At this stage, our build looks something like this from level 1 inside, and like this from the ground level outside, where we can also notice installation of posts and deck joists. And while the work has been proceeding on the upper levels, we bring in the plumbers and electricians to commence their work in the wall and ceiling cavities, before placing fire-rated insulation, in this case rock wool, in the walls and ceilings. Insulation helps to control temperature and sound transfer, reduces heating and cooling costs, acts as a fire retardant, and is an integral part of the wood frame construction system. Meanwhile, our roofing work has continued, while scaffolding has been erected along with external stairs and decking. Good quality scaffolding is essential for high work, for detailing of roof lines, installation of gutters and downpipes, and for attaching weather shield and cladding to our exterior wall surfaces. For the waterproof weather shield, we used tie deck home wrap, which is specially formulated to repel direct rain while allowing diffusion of water vapour from inside the house to the outside. The process is straightforward. The care must be taken to ensure positive overlap and correct fastening so as not to allow a moisture path through the tie deck. See, all these little details are important in this system. With our plumbing and electrical wiring installed and insulation fitted, we can commence work on interior wall and ceiling lining. 1/2-inch gypsum board is recommended due to its fire resistance and inherent R values. For added insulation, noise abatement and fire resistance, we have the option of adding a double layer of gypsum board to our walls and ceilings. In India, your choice of external cladding is an exceedingly important one due to the extreme and variable climatic conditions. We get a lot of questions about this, from hot and dry to extremely wet and humid and everything in between. If wood is your choice, please select durable wood, pre-coated at the factory with a primer and good quality penetrating coat with a UV inhibitor. And remember, it's important to seal all 6 surfaces of the wood. This slide shows an example of factory pre-coated spruce pine fir and western red cedar claddings with a final coating added at the job site, which in this case was IndiaWood 2020. We must understand that cladding provides our first primary barrier to water resistance, while weather shield and wall construction provides our secondary barrier. On this slide, we see a simplified progression from the stud wall sheathed with OSB, then with the base flashing added, then waterproof weather shield overlapping the flashing, followed by pressure-treated furring strips with insect screen attached at the base. Quite an important sequence. The 4 Ds of waterproofing our building are worth remembering. Deflection, which is allocated maximum 5 stars. That's all about design. Drainage, 4 stars. Drying, and use of durable materials. When it comes to cladding, technique and attention to detail is crucial and will determine if your walls are waterproof or not. In this illustration and mock-up, we can see home wrap weather shield applied over OSB with positive overlap. Next, we see furring strips attached over the weather shield. And these must align with the wall studs, as we will be nailing our cladding through the furring strips. It becomes clear when we attach our cladding over the strips that we are creating an air cavity between that cladding and the weather shield. So if heavy rain should penetrate the cladding, it will drain out via the air gap and will be directed away from walls and foundations by the base flashing. As mentioned earlier, mesh screen is installed at the base of the air gap, giving us an insect barrier while allowing any water to drain through. It is important to understand the base flashing is attached on its vertical plane directly to the OSB wall sheathing, as opposed to the termite flashing, which is attached on its horizontal plane to our foundation. The reason I mention this is that the termite flashing and the base flashing can sometimes overlap, as can be seen within the red circle on this slide. But both are separate and essential elements. So with the cladding and roofing complete, windows and doors fitted, the house has reached lock-up stage. Our structural work is complete, door frames and window trims have been installed, and interiors are ready for painting, electrical fittings and decoration. And with the landscaping done, bathrooms and kitchen tiled and fit out complete, we're ready for our grand opening. This is what people came to see. Meanwhile, in Hyderabad, our partners and CAD services provider, a company called Ascent CAD Services, built this wood frame construction house. I wanted to show it because we can see the owner elected to use non-wood cladding. In this case, a mixture of brick veneer and stone veneer claddings. Now, of course, this is absolutely fine and sometimes a wise choice. For instance, on west-facing walls, which are exposed to direct afternoon sun, or wall surfaces which, due to orientation, tend to bear the brunt of severe weather events. And I wanted to again show this version of the wood frame construction by Pyramid Timbers because it was factory built in 3 modules, as I showed earlier. So it's a little variation. Roof trusses came in 4 sections. The entire house was transported from Mysore on 4 trucks to IndiaWood Exhibition Hall in Bangalore, where the modules were offloaded by crane and the house assembled and finished in 4 days. Pretty impressive. Each module was completely finished at the factory, inside and out, including gypsum walls, you see here, including the kitchen and bathrooms, other than the appliances, and including built-in furnishings. Spruce pine fir panelling and faux beams, and Western hemlock and Douglas fir furnishings by Mars Furniture. Just yet another version of impressive wood frame construction made in India. That completes this overview of our 3 building styles and the different methods involved, but it would be remiss of me not to mention there are many common design details which apply to timber structures, no matter if they're post and beam, prefab TNG, or wood frame construction. Details which are common to all 3 building styles include flashings intended to divert or control water movement, such as head flashings above windows and doors, step flashing applied along the roof to wall transition, diverter flashing, peel and stick flashing, overlapping of flashings with our weather barrier, drip edge flashing along the roof line, and waterproofing of roofs and decks, installation of gutters and downpipes, ventilation, cladding choices and landscaping. All of these things, all of them and more, are common to all the building styles that we've reviewed today. So I hope today I've covered the key details about which you may have had some doubts, such as foundations, strength, termite mitigation and weatherproofing, which are more relevant to those who are actually doing the designing and building. Things like concrete work, engineering, plumbing and electrical trades, damp proofing, and importantly, roof design and execution, which is again a system to be followed, means no shortcuts. I don't intend to delve into these areas, which can be left to the professionals to execute. But it would make me very happy to see roofs like this across, or like these, across India, rather than these. You know, I think we've all seen this. This example, these are poorly executed single TNG resort cabins in Goa. There's no attention to detail or best practice, all built to the lowest cost. But to be fair, you know, even in my own society here in Mumbai, where I live in a steel reinforced concrete building, which is only 12 years old, it's accepted that we must place tarpaulins over the clubhouse roof during monsoon. Now, why is that? You know, there's only one reason: because of substandard, low-cost design and execution when the clubhouse was built. And we see this so often. In my opinion, this is false economy and it's unacceptable. So in wrapping up, I'd just like to leave you with this thought. Design is everything. Clever design, which considers orientation, cladding materials, shading and screening, glass area, roof lines, natural ventilation and mechanical ventilation, such as HVAC and humidifier systems, will have a huge impact on the performance, longevity and maintenance schedule of your timber project. When it comes to wood, good design will incorporate mitigation strategies for all the questions you may have in your mind. And remember, millions of wood framed houses and log houses are constructed all over the world, every year and in every climate, from below freezing to tropical to arid. It sounds very much like India to me. So all you need to do is execute. So a big thank you from me and the team at Canadian Wood for attending this webinar. I hope it's been informative and that you will consider using Canadian Wood in your projects. Now I'd like to open the floor to your questions and discussion points. Hopefully they've been passed along to our coordinator today, Ajay. Thanks.
Thank you, Peter. That was a wonderful presentation, and thank you, audience. Thank you for the overwhelming response. We had around 140 participants today, prominent architects, developers, and from hospitality industry representatives. And there are lots of questions for us. And what we're going to do is, yes, we will try and answer most of the questions, as many as we can during this webinar. And in case any of the questions are unanswered, we will definitely get back to you through email, and we will answer your questions. That's a promise from us. We will make it as an interactive session. So what we'll do this time is take few questions. We will try and unmute some of the attendees who are asking questions to us. So we will do it on first come first basis service basis. And we have our first question from Mr. Ratan Batliboy. So Nirmala, if you can unmute Mr. Batliboy, he's an architect from Mumbai, a well-known architect. And first question from him, Mr. Batliboy.
Yeah, Ajay, he's unmuted. Yeah. Yeah, Mr. Batliboy, could you unmute yourself too? Yeah, it's okay.
Yeah. Thank you, Peter. That was a fabulous presentation, as always. There are so many ifs and buts in this whole construction. If this is not done correctly, that is going to happen. If that is going to happen, then you're going to suffer. Basically, my simple question is, what is the support from Canadian Wood that we could expect in the design, the manufacturing, and the supervision at the site installation? Also going forward in terms of exercising the warranties and guarantees that we're being given, and the annual maintenance, because I expect that a lot of the life cycle and longevity and the support will be primarily from how we look after our timber constructions once constructed on site.
Yes, that's quite true, Ratan, and starting from the last bit there, the maintenance schedule will be important. I think it's important though in any building style. If you only need to look around concrete buildings in Mumbai to see that maintenance is often sorely lacking. So timber structure, I think as long as we incorporate good design, let's not put a wood wall facing the afternoon sun. That's probably not a good idea. Let's employ screening, shading, overhangs, that kind of thing. So long as we do a good job of the coating on the wood, where we do use wood externally, that maintenance is really relatively easy. So long as it's done properly the first time, the maintenance is a quick sand and one coat, maybe every 18 months, maybe every 2.5 years sometimes, or 3 years, just depending on location. I don't think it's onerous, and timber buildings and timber cladding is used all over the world in all sorts of climates. So nothing unusual to take some pride in that and to maintain it adequately. In terms of support from Canadian Wood, yes, we are here at your service. We can certainly offer technical assistance. We can take your architectural plans and drawings and perhaps suggest a CAD services provider, or where necessary, a structural engineer. Those services are generally a fee for service, deal. So we can point you in the right direction and certainly give the basic advice. We can certainly recommend the right applications for the right species, the grades and sizes. We can put you in touch with suppliers. We do have a contractor here in India that is doing the oversight and project management on all those projects I showed you today, or most of them. We've had project management present here. We may have to increase the level of project management that we have available. It just depends on how many projects we're working on at one time. But he can move around. So I guess, we're at the end of the phone. We can put you in touch with qualified people. We can recommend the correct species and grades and applications. I think we can, answer your technical questions, and if we can't, we'll find someone who will. So yeah, I'm really confident that we can help you and others with such projects. we can't spend 100% of our time there on the site. They can certainly devote some time, and we can also help with some remote advice and probably providing some training. Training is really important for the workforce and for staff involved. So that's something that we are doing already on a smaller scale. Probably that's going to have to grow as we start to grow the number of projects.
Thank you.
Yeah.
I hope I answered that question, Martin.
Yeah, that's good. Thank you.
Thanks for it.
A lot of questions that we can keep talking about, but I don't know how this one. Thank you.
Yeah, thank you, Mr. Bartley boy.
Thank you.
Yeah, so our next question is from a developer, the managing director of MAC projects from Hyderabad, Nawab Mir Nasir Ali Khan. He has a question for us. So may I request Nirmala if you can unmute Mr. Nasir Ali Khan?
Yeah, Mr. Nasir Ali Khan, can you? Yeah, he's unmuted.
Yeah, I can hear you. Good morning, Peter. Good morning, everybody.
Hi, Nasir.
Very, very good session. Very informative. It's a great learning experience for us. And I know wood is being used globally in North America and other countries, but it's new to Hyderabad and new to India. So you will be supporting us in design development for the first and train our people. In the long term, we really don't know what are the issues with maintenance and with weather. How will you be also supporting us and assisting us in maintaining for some time, or training our people to maintain it on long term?
I think it's a must, Nasir. Yeah, as you know, we are working on the project there, but there'll be a significant training on the job training. We're also doing some independent training with another instructor that we brought over from Canada on 3 occasions so far. So I think we might have to expand our online training. But yeah, for future support, we don't expect that you're going to build one house, with our support, and then we just, say great, and walk away and go to the next project. Clearly, when you actually do some commercial building, you'll need ongoing support. But I expect it'll be, part-time and, just occasional attendance at site, and as long as you can contact us and get the answers that you need. I think that's critical, and we'll definitely be there for you on that.
Yeah, Peter, thank you. That answers my question. But we will learn, and if there is support from FII for initial period of a couple of years, then I think it will be fine. Then we will learn. We've been in conventional construction now, this new area, but we have a lot of experience in building and maintenance. This is new to us. We will learn. I mean, if we can learn to maintain wooden buildings, then I think in the long term we'll be able to handle also. Yeah.
I do. I think, you have outstanding carpenters here. It's only a question of, familiarity with this system. And as I said, it is a system. So, once it seems complicated, but actually once you understand the steps and the reason for the steps, it's not hard to learn. And we've done a lot with our on-site manager here, Master Builder, Stan. He's temporarily back in Canada right now, but he has done a lot of on-the-job training. A lot of those houses that you saw today, the young builders and the principals of the companies, they've been very, very impressed and very happy working with Stan. They've learned a lot, and they're already looking at doing commercial projects on their own, after building one display home. So, yeah, we'll continue that. And if we have to, I guess if we have to increase our presence, with someone else on the ground here, that's something we'll consider.
Thank you so much, Peter. Thank you very much.
Okay, thank you, Mr. Khan. Our next question is from an architect, renowned architect from Gurgaon, from Akar Design Consultants, architect Gurpreet Singh. So may I request Nirmala to unmute Mr. Gurpreet Singh, please?
Yeah. Hi, Gurpreet. Could you unmute yourself, please? Yeah.
Is that done, Nirmala?
Yes, thank you. Yeah.
Hi, Gurpreet. I can hear you.
Hi, good afternoon. Thanks a lot, Peter, for your wonderful presentation, and I think it is really good. what I liked about the presentation was the constructional details that accompanied the pictures and the pictorial, This almost gave us a feeling of our, back in the college days, wonderful. I think it's a very nicely put together effort.
Thank you.
Now, what I feel here, Peter, is that, when it comes to timber construction, we need to now open up more avenues, large scale projects and go beyond houses, homes,
Yes, yes.
into public buildings, public spaces, because I think wood is such a rich material that people, across the larger spectrum need to experience the warmth and the joy of timber and wood, that's what I meant, in terms of public buildings. So are you looking at any projects of that scale? One is resorts, of course, beyond that.
Yes, I would say absolutely, Gurpreet. In fact, we have already completed, I didn't include that project in this presentation, but we have completed a commercial project in Ahmedabad, as you know, at Sept University. Now, that was a brand new workshop, or basically three adjoining workshops, where we bought, 11-metre laminated Douglas fir glulam beams, or arches actually, to India from Canada. It's quite a beautiful structure, and we use Canadian wood throughout. We're also looking very closely at some other big projects, big school projects, and commercial projects. There seems to be a lot of interest in engineered wood. I talked about glulams. I didn't really get into those other engineered products like cross-laminated timber and I-beams and LVL. There's a whole raft of engineered products which make it much easier to build multi-level commercial buildings. No one's actually making those products in India right now, so they have to be imported, which is a slight impediment to doing big projects. But if someone really wants to do something that's outstanding and visible, we can certainly help and accommodate and bring those products from Canada. There are a couple of manufacturers here in India that are starting to make glulam products of pretty high quality. So yeah, that might work also. But of course, in commercial projects, not all about structure either. It's not about necessarily building a skyscraper right off the bat. It might be as simple as building the clubhouse, building the, offering product for those outdoor areas, exposed areas, paneling, decorative screening. There's lots of applications that we can apply to commercial projects using Canadian wood, and we're doing that already.
Yeah. Thanks, Peter. This is really good and informative. Nice.
And I hope we can grow into that commercial space. I heard on the news this morning that we're going to build the tallest hybrid structure in Sydney, in an area that I know very well, using glulams and CLT.
Yeah. Wow.
Yeah.
That's exciting. Thanks.
Thank you, Gurpreet ji. Thank you, Mr. Singh. I hope we have answered your queries.
Yes, thanks, Ajay.
Yeah, so Peter, I think we have around 20 odd minutes and there are lots of questions pouring in. So I think we have time for 2 more questions from the audience, and then I will run through the balanced list of questions.
Sure.
Our next question is from another senior architect from Gurgaon, Mr. Jitendra Singh Dhanjal. And may I request Nirmala to unmute him, please. He represents Inex Architecture from Gurgaon.
Yeah, unmuted, Jitendra. You can go ahead. Yeah.
Yeah, good morning, everyone. First of all, I'm from New Delhi, Safdarjung Enclave, not from Gurgaon.
Yeah, okay. So,
Hi, Jitendra.
Yeah.
Thank you so much. Very nice presentation by Peter.
Thank you.
Very informative, especially the detailing part. I love that. My question is that, are any structural codes available with you for designing these wooden buildings? If yes, then are these approved by Indian standard codes for getting approvals from authorities for construction? Because if you're looking for high-rise building, or public buildings or some other buildings of importance, then we should get these approved from our authorities like NDMC, MCD. So are any codes available?
I agree. All the structures that you've seen today, Jitendra, are based on North American standards, or Canadian codes. There's an organisation in British Columbia called FP Innovations, a professional organisation, and we've had them take a close look at the Indian Building Code, and we've done a comparison of the Indian Building Code versus the Canadian or North American Building Code, actually. There is a gap in the Indian Building Code in terms of using wood. There's nothing there to say we can't do it, but there's no real detail around it. So I think, once we start seeing projects, commercially viable projects, then, it's going to be necessary to engage with the Indian authorities. Now, that can be done from an industry to government level or government to government level. But certainly, I think that will become necessary. But right now, as I understand it, we don't seem to be having any issues building these timber houses. I think we just get the permission from the local authority. But yes, it's a good point that you raise. And I don't know all the ins and outs of what the code will allow or won't allow. I don't really think it's going to be a problem. We faced the same challenge in China, FII, and building wood there. And that China integrated the North American codes into their own to allow it to happen. So now there's a huge timber building activity in China.
So any efforts been processed with the Indian standard authorities or governments till now? Or
not directly, as far as I know. We can share that report, the differences in the codes. We have actually shared that report with a number of eminent architects. We're happy to share it with you also for comment. So we would like some feedback actually from local authority or local architects and or authorities based on what we've already produced. So as I said, I think it will need to happen.
Yeah, because most of the buildings requires these approvals from authorities. Because in a private houses or a farmhouses, we can make these kind of wooden houses and cottages where sometimes approval is not required.
Right.
But to get more construction of these kind of wood structure, we need definitely approvals from the authorities. Okay. And they will check our calculations, and structure engineers are also need to be equipped, and they need to be guided and advised about your codes and your standards and your detailing, so that they can also help us design our buildings. Yes. Because architects won't be able to design all the structure for the buildings. So I'm sure that you are helping us deciding on the sizes of all members. Yes. But if the structure engineers are also provided this information and they are also helping us designing building, that will be better.
Yeah, very important, very important. And we have a specialist timber structural engineer here in India. Okay. But that knowledge needs to become more widespread. I agree 100%. Sorry, Ajay, go ahead.
Yeah, so I mean, thank you, Mr. Dhanjal. That's a valid point. Yes, so we have been working with structural engineers, but that's project to project basis at the moment. And as far as ground plus one level structure, we haven't faced any issues. There are local authorities who have been approving these structures, but mostly it's being second homes or the hospitality projects. That's where we have got success. But yes, there have been attempts made in, for example, there is a project being explored in Hyderabad at the moment, which is, 5-story structure being built with wood. But yes, I mean, we have been providing all the technical assistance and the literature, because we work very closely with University of British Columbia. At the same time, FP Innovation, which is a world-renowned body on, timber details in terms of structure or species or technical properties. So we have been providing that support on case-to-case basis. Yeah, thank you.
Thank you so much.
Yeah, you're welcome, sir. The next question is from Mr. Sanjeev Day. So if I may ask Nirmala, I think that's the last question we'll take from audience, and then I'll go through the questions in the Q&A tab. So can we unmute Sanjeev Day, please, Nirmala?
Yeah, Sanjeev, you can go ahead.
Yeah, I haven't unmuted. Thank you so much. Peter, once again, congratulations for a fantastic presentation. Very technical and very useful. Peter, my question is pretty much similar to what was asked just before this. It's about us architects designing with wood. And what kind of structural engineering support do you provide? While we do not have too many engineers in the Indian industry just now who can help us in with our optimizing our sections, wood sections.
Yes.
Do you have any metrics for the time being which we can use to use the optimized sizes while we are using them on various spans and pitches?
There are span tables available, and they're quite product specific. So each species will have different values, and as you know, and also blue lands and engineered products will have their own values. So there is a metric, or a variety of matrices which can be used as a rule of thumb, and it is important to engage a structural engineer if once we get into any structure that's ground +1 or ground +2 or commercial, and we have that expertise here with us in India, but we need to expand that. I agree. It is a fee for service, a procedure for architects. We can introduce you and help with advice, but in terms of the structural engineer's work, his expertise, he will charge for, and he will charge the architect for that. But it's money well spent. It's absolutely money well spent up front, because it means that you can have full confidence in the structural integrity of what you're proposing. You'll know the spans, the end sections, the connections, the correct species. All the detailing will be provided by that structural engineer, and it's a one-off cost up front, but usually you're going to apply that knowledge across a project. It might be 20, might be 60, keys, and so once you ameliorate that cost across all those, the full project, it doesn't really work out to a lot of money, and I think it's really a good investment. So we can help with that. We can introduce you to that person, or alternatively, we can find some expertise in British Columbia itself.
Is he going to take the questions?
It's useful to know, Peter, that Canadian Wood would support us while structural engineering is still coming into play within the country. Just one quick one, which is, does it change with every wood? Like, is it different for Douglas fir, or would it be different for SPA, for other woods of Canadian wood, or are they usually the same?
In terms of spans and end section, yes, there's a little difference. Not a big difference. You might be surprised to know that Douglas fir actually is as stiff as teak. So it's really quite strong. It's quite well renowned for its strength and stiffness. Whereas hemlock, yellow cedar don't have quite the same value, but still okay. So yes, it's a little different per species, but not a huge differential.
Sure, Peter. Thank you very much.
Yeah. Welcome. Yeah, thanks, Sanjeev. So I think, Peter, we have around 10 minutes to tackle lots of questions. So I'll try and cover as many as I can. Okay. We have a question from Mr. Om Prasad. He's asking about what kind of species of trees are we suggesting, oak, teak, etc. So just one quick clarification, Mr. Om Prasad. These are all softwood lumber species from British Columbia. So Western hemlock, Western red cedar, yellow cedar, spruce pine fir, Douglas fir. These are the 5 group of species. And for structural applications, what Peter had been suggesting is mostly either Douglas fir or spruce pine fir, depending on the type of construction method that you are using, whether it's a post and beam or a double TNG. So accordingly, we can choose. And our representatives definitely will touch base with you to explain more on this. We have next question from Deepak Gehlot. He's asking about how do these structures perform under seismic load? And we have several such questions about seismic load and fire. So if you could give a quick brief on that, Peter.
Well, I would say they perform exceptionally well under seismic loads. It's in fact wood in general is a superior product in seismic areas, simply because of the way wood is connected. And so there are. If an area is struck by a movement, there are load paths through the wood and through the nailed connections, which allow that building to flex and move without collapsing. contrary to, you know, or compared to what we saw in New Zealand years ago, of course, where concrete and steel buildings collapsed and pancaked onto one another, and there was a lot of loss of life and a lot of destruction of buildings. So a lot of these regions that have been struck by earthquakes or earthquake prone, such as Japan and New Zealand, are rebuilding in wood. So wood just has that property that where it's able to move and flex and transfer the energy. So yeah, absolutely superior. And there's a lot of information online that you can access. And there's a lot of ancient timber structures in places like Japan that have stood for centuries through hundreds of earthquakes and are still standing.
Yeah, thanks, Peter. Next question is from Urvi. She's asking for prefab timber construction, what's the minimum size of workshop or the factory setup that's required?
Good quality. Good question. I'm not the best person to ask on that. I'd need Stan to tell me, but you know, it's not huge. It just depends on the, you know, the scale of the enterprise you're involved in. So, you know, if you're setting up a production line, you know, and you're making roof trusses and roof frames, you'll need to actually install tables, roller presses, clamping systems, that kind of thing. So I'd only be guessing at the square foot area or square meter area, but you know, you can start small, and I think that's what probably the important thing that I'd suggest is you start small, whereby you know you have a space, an open space, with an overhead crane, hopefully, where you can build walls and wall panels and roof trusses inside, and you'll need a big opening to obviously transport them in and out, and load those on a truck. That's a starting point. And that work can be done on a concrete floor, or it can be done at waist level on a bench, and the bench can be fairly unsophisticated to start with. So I don't see it as a huge investment to get to set up, and I think from that you can, you know, you may grow depending on the level of activity you find. That will grow, and obviously you'll need more space.
Okay. Next question is from architect Puneet Pandey. He's asking, in fact, there are a couple of questions from him. Termite issues and fire retardancy, how do we achieve that in these timber structures? Yeah. I know you have covered it a bit in your presentation, but if you can give your...
Yeah, no, I have. And I would encourage everyone, you might not want to sit through it again, but when you get a chance, I'm sure this has been recorded. So if you get time to review it, you will see the actual examples of, but they're common questions and obviously important questions. So, I mean, I think the first barrier against termites is the groundwork, the ground preparation, the application of termite treatment to the ground, the use of, you know, a good well-poured concrete foundation. Concrete quality is important. You don't want a lot of air cavities in the concrete. Then we use physical barriers like the metal flashing that I showed in the presentation. So metal flashing protrudes out from the side of the edge of the building at the concrete, at the foundation level. And it has some angles and bends in it so that it makes it very difficult for termites to build their tunnel up on the outside of that. So there's a physical barrier. Then, of course, I would say it's really important to use termiticide treated, or preferably pressure treated wood at the foundation level. So for base plates, floor joists, perhaps even you know, fairing strips on the walls, that's really important to use a pressure treated wood or a naturally durable wood. So all these steps will help mitigate the problem of termites. If we're building on posts or pylons, we can use, again, a metal cap on that post or pylon. We just need to stop and restrict access to termites from the ground to the wood. So where we can cut off that pathway, that's what we do.
Yeah. Yeah.
And
Thanks, Peter.
was there another part to that question, Ajay?
Yeah, so it was termite and fire.
Fire, yeah, okay. So our fire resistance comes mainly with the insulation and the gypsum board in the interior of the house. The thing about wood is, you know, we all know and understand that wood is flammable. So if a timber house with timber cladding is facing, you know, a hot fire front, there's a very good chance the wood's going to ignite and burn. Now, the good thing about wood is that it tends to self-extinguish, and generally will self-extinguish within about 10 minutes. And when it does that, it creates a char on the outside of the wood, which in itself becomes a fire inhibitor. And so the object with timber buildings and timber frame buildings is to allow a fire to pass and to allow safety, sufficient safety for the occupants to remain there for 1 or 2 hours and then evacuate the building. The main thing is to get people out rather than save the building, but it'd be good if we could save the building. And I think, you know, the standards, the building standards and building codes in North America are quite strict on that tolerance to fire. And that's the same standards and codes that we're using here in India.
Yeah. Okay,
so sorry to interrupt, Ajay, we just have 5 minutes more.
Yes. Yeah. Thanks, Nirmala. So I'll try and cover as much as I can. We have a question from a structural engineer, Apurva Ragi. He's asking about the deflection properties, the bending stress coefficient, the shear stress coefficient, and, you know, different structural properties, modulus of elasticity of different timber structures. So Apurva, I mean, we will get back to you. We have all this information documented, and there are brochures available which can be downloaded from our website, canadianwood.in. So what we'll do is immediately after this session, you know, our representative will touch base with you and share all these technical details. And these details are available, you know, as a free download from our website. Next question is from architect Siddharth Das. Yeah, so Siddharth's question is about, you know, are there many executors whom, you know, you would recommend across India who will follow best practices? So I'll take a quick, you know, answer here. Siddharth, see, we have been conducting various training sessions. So far we have trained 36 different wood builders across the country. So 36 of them have attended basic level of training. We have also conducted an advanced training in Mysore, again, pan-India basis, around 14 wood builders who have shown interest, and all the serious folks, you know, who intend to build with wood. So we have been continuing this. So we got a trainer from Canada who came here, and it was an extensive 14-day training. Okay, so everyone was committed for that, and it was a practical training. And we have also been executing certain demo projects, and Peter has already shown some of those images, you know, one in Chennai, one in Bangalore, there is something, you know, a couple of them in Mysore, one built in Goa, there is something in Pune, you know, so that we are spreading our presence across the country step by step. So yes, to answer your question, we have been working with the house builders in India and working very closely. Even a structural engineering support, as Peter has mentioned earlier, you know, so there is a consultancy firm from Canada who have now opened their office in India, Katera. So, you know, we have been giving that project support, engineering support also from India. Okay, we have a question from Aditya Mane. I think he represents a development company. I could see a lot of homes and resorts. I'm sure this is used in clubhouses as well. What's the maximum span we can get in timber structure, Peter?
Well, in solid wood or engineered, that's the question, you see. So if we need long spans, then we need to go an engineered product like a glue lamp. But if we're using solid wood, then, you know, is it a clear span, or is it, you know, is there an intermediate member? It's just a question of the design. You will have noticed in those post and beam examples that I showed, there are very, very wide open spaces achievable using wood. Pretty much we can imitate steel in most cases with a wooden product. So there's no really hard and fast answer. I could maybe ask what span are you, is he thinking of, Aditya? What span is it that you're considering?
Yeah, so we can probably take it offline with Aditya on that. But yes, different spans are possible, as Peter suggested, whether it's a timber solid section or a glue laminated section. Accordingly, we can, vary the span of the structure. Just one last question, and I think there are a couple of them who have asked. Varghese Ukken is asking about climate and humidity. How do we treat that? And Anshul Choda, who is an architect, he's also asking about heat, rain, humidity, different challenges in Indian condition. How do you tackle those? And there are many more questions, but as we progress, again, he also wants to know about structural engineering support, which is not as readily available in India. So if you could touch base on those, and the rest of the questions, I think we'll have to, answer them back through email. But we will definitely attend to those questions. Peter, humidity, temperature.
Okay, so look, I spent a lot of time on that rain screen wall application that we see in a wood frame construction house. So we have a backup. So your first line of defense is the exterior cladding, and that's mitigated by overhangs, by good design, by orientation, by screening, by shading. These are all important factors. It's all about good design and cladding materials. But essentially, all of these buildings I showed you are absolutely waterproof and weatherproof. We utilize all sorts of help in achieving that, from that rain screen material to the air gap to the flashings and so on and so forth. Really important. Probably the same applies to tongue and groove buildings, depending on which claddings and which exteriors you're installing there. In terms of the tongue and groove style of building, the coating is very important. Now, with the tongue and groove, we're endorsing a thick, at least a 65 to 70 millimeter thickness wall, solid wood. So that in itself is a strong barrier to weather, so long as it's properly sealed and properly coated. And it should be pre-coated on 6 surfaces in the factory and finished off at the job site, and all the correct procedures followed to mitigate shrinking issues and exposure issues. So yeah, I think it's pretty much covered in the webinar. It is a concern for everyone, but as I mentioned, these buildings are built all over the world in all kinds of conditions, very similar to India's, and they last for many, many decades, no problem. So long as the system is followed, we don't take shortcuts. That's what I must always emphasize.
Yeah, and thank you so much, everyone. We will get back to you. I know there are a lot of questions asked here. Thank you for your overwhelming response. We will get back to you. And there are a couple of questions also being asked, like, can we get a copy of this webinar? So yes, we will share the video recording of not just this webinar, but I think some of us are also asking about the first webinar. So we will share that with you. Yeah, over to you, Nirmala.
Yeah. Thank you, Ajay. Basically, thank you everyone for attending this session and being patient with us. A lot of questions. I know it's very difficult to answer all of them in one go, but yes, like what Ajay said, please do keep in touch with us. We have a very information-rich website. You'll get a lot of information there. Do visit our website and also be in touch with our team. They will come back to you with all the answers. Basically, just after the webinar, you will receive a survey link from IndiaWood, which will be sent directly to your registered email IDs as you have registered. Request you to kindly fill this feedback form and share back with us. Feedback and suggestions are most welcome, helps us do better. We look forward to seeing you again. Do attend our next series of webinar, date of which has to be still announced. It will be in continuation to the webinar series Wooden Structural Use, but a different take. So before I end this webinar, I would like to invite Pranesh Chibber, Country Director FII, to say a few words. Once again, thank you for attending.
Hi friends, many thanks for taking time out to attend our second in the series of webinars on wood and structural use. And hope you found it informative and useful. We are really overwhelmed with the response to our webinars, which has encouraged us to look at expanding the format of our next webinar. It is titled Architecture with Wood in India, scheduled for 24th July. It will be 1.5-hour session featuring 3 doyens of architecture in India who will share their works involving wood and engage in a panel discussion. This webinar will be curated and moderated by an eminent senior architect who strongly believes in wood as the next most important building material of the future. We are also working on bringing you soon a webinar featuring prominent personalities from the world of architecture and structural design engineering from BC, Canada, tentatively scheduled for August 2020. These will be followed by webinars on other popular reman applications such as furniture, door window frames, interior and outdoor applications. And you will get to hear about these dates soon enough. I hope Peter has been able to address some of your queries on wood as a building material and clear many concepts. We understand that going forward, while considering wood as an option for your projects, you would have many more questions. Please feel free to connect with us and we'll be happy to respond to each and every query received. Best way forward in such cases is for you to share your project details with us right from the inception, including drawings and plans. This helps us handhold and guide you through various aspects of building with wood, including connecting you with related wood professionals. Thank you once again and look forward to connecting again soon. Have a great day. Take care. Stay safe in the new normal. The webinar ends now.